All right, guys, so now I'm going to go through the November 2013 paper 2. All right, this was what you used for your mock. Now, again, I'm not going to answer every question. I'm not even going to work out most of them. But what I'm going to do, though, is I'm going to talk through some of the common mistakes and hopefully help you out with your error analysis and trying to put some pieces together. All right, so this was the first question. Okay. Given that f of x equals 1 over x, most people found the first 4 derivatives just fine, and then they had a hard time writing the expression. So I'm actually going to have to write this out. So the first derivative, well, let's just start with f of x. So f of x was x to the negative 1, so the second derivative was negative x to the negative 2, so negative 1 x to the negative 2. The second derivative would then be 2x to the negative 3. The third derivative would then be negative 6x to the negative 4th. And then the fourth derivative, that could be written IV. But yeah, then negative 4 times negative 6 is 24x to the negative 5th. All right, so here's what you need to do. You have to look at this and say, okay, what patterns do I see? When I'm trying to write an expression for a general thing, unless I have some type of formula, like for sequences and series, I'm going to look at patterns. All right, now I look at the exponents, and a lot of people got this part. You notice that the exponent was increasing by 1 each time. You notice that it was always negative. And then most of you notice that this number, the 5, is 1 more than the 4. The 4 is more than the 3. The 3 is 1 more than the 2. And so you ended up doing something like this. You said x, and then you said, well, the exponent's always negative, and then whatever the n is, it's going to be n plus 1. So n is the power of the derivative. So if it was 4, it's 4 plus 1, which is 5, but then it had to be negative. So you ended up with something like this. Some of you wrote x to the negative n minus 1, and you just distribute the negative. That's fine. Okay, so check. We got the exponents done. Okay, now we're worried about the coefficients. Now, you saw that this was worth 1 point. Originally, it was worth 3 points because there's 3 different pieces. One is that. Now, the next thing you notice is, well, the coefficient's changing. We're going to worry about that last. Look at the negative, right? You got a negative, you don't have a negative. You got a negative, no negative. So something's happening each time to get the negative to change. All right? Now, you'll notice that it's negative when it's odd, and it's positive when it's even, right? Third is negative, so odd, and fourth is even, so it's positive. So what we can do, notice that to change the sign in front, all we really need to do is multiply by negative 1. And then, but if I always multiply by negative 1, then it will always give me a negative. So what I'm going to do is I'm going to do negative 1 to the n. Everything needs to be related back to n. All right, so if n is 1, then it'll be negative 1 to the first power, which will leave me with a negative. If I put a 2, then it'd be negative 1 to the second power, which will make it positive. Okay, so even numbers will make it positive, odd numbers will make it odd, will make it negative. All right, now for the last part, we're going to look at the coefficient, 1, 2, 6, 24. And at first glance, you may say, well, there's nothing going on there. Well, this one's just 1. Okay, this came from the 1 being multiplied by the 2, so it's 1 times 2, right? Now the 6 is that 2, which was 1 times 2, but then you also multiplied it by the 3, so then it got multiplied by 3. And then the 24 is that number, the 1 times 2 times 3, which is 6, and then it was multiplied by the 4 when the 4 came in front. And so hopefully you recognize that pattern, and you need to come up with a way of writing down something related to n. Note that the largest number is always the derivative. 1, 2, 3, 4, right? And so we need to come up with some way of relating that to n, but being able to multiply everything below it. And you may or may not remember, but that would be n factorial. And so this would be your final answer that would answer that question B. All right, let's move up. Most people got question 2 right, x-intercepts, even doing the integral. It was calculator active, so hopefully you just put that into your calculator and you were able to do that without too much of a problem. All right, so I'm not going to go into that. Most people were just fine there. Most people that didn't do well, it's because you tried doing it by hand. It's okay to use your calculator. Just write out the thing, right? We're going to go the integral from one x-intercept to the other, so from 1 to 4 of x minus 1 x minus 4. Now remember, to get the volume, it's going to be pi and then y squared. So you're just going to square this, and you put that in your calculator, and you should then get the volume. You can also just put in this function for f of x and then do a calculate, right? You can calculate the integral from 1 to 4. Unfortunately, that will only give you the area. It's not going to give you the volume. So to get the volume, you're actually going to have to write this out. You can write that out on the home screen, but you do have to recognize that you're using that formula. Okay, most people were fine with this one. If you made mistakes, it was usually because you didn't rewrite this. You need to rewrite that as x to the 4/3. Okay, the power is on top, the root is on bottom. Once you do that, this is fairly straightforward to do both the integral and the derivative of. Okay, on to question number 4. Most people did fine on part A. Part B is where people started to have a hard time. They are independent. Since they're independent, you can use the law for independence. You can also use the equation from the equation booklet. So boop, there's my equation booklet, and you'll see these ones, mutually exclusive, won't work. Independent will, conditional will, combined will. Independent works if they're independent, which it states. So I can use that P, A, and B. So P, A, and B is equal to PA times PB, right? So because it says independent, that's probably going to be useful. Okay, the other thing is, well, I have, of course, the union there, and so I'm going to use the one that has union, which is combined. This one always works, and so it's just going to be the probability of A union B equals the probability of A plus the probability of B minus the probability of A and B. Now that should make sense that always works, is the union is just everything that's included. This is all of A and all of B, but then you do have to subtract off if they overlap, which is what this is talking about. So now from this point you should be able to put the two together, right? You should be able to take the PA and PB and put it in right there. You know AUB, which is 0.5. You know the probability of A, which is 0.2. You don't know the probability of B, so plus X minus A and B, which is A, which is 0.2, times probability of B, which is X, and you should be able to solve it from there and get the answer to 4B. Alright, so the key there was that it does require more than one law of probability. Don't be surprised if a later question, you know, a later part of a later question requires you to use more than one law of probability at once. In fact, most of the time that will be the case, because they really aren't worried about, can I use a single equation? They want to know, can you put ideas together? So just be aware, you could use more than one equation. Same thing with trig. You could very easily use more than one trig equation at once for like the rearranging and things like that. 5, I'm not going to go into. Most people did just fine. If we look at question 6, again, most people did fine on A. Part B, people had a little bit harder time with. If you drew a picture here, it's definitely helpful. So this is a normal distribution. So if I draw my normal distribution there, it says the mean is 20 minutes. So this is 20 right there. And then the standard deviation is 1.25. So standard deviation equals 1.25. And a student is selected at random. Find the probability the student completes the task in less than 21.8 minutes. So that should be this one right here. Part A would be this right here, 21.8. Now, that should be easy enough. That would be this whole area. You can do that. I'm not going to go into that. If you have questions, please come ask me. And the probability that a student takes between K and 21.8 minutes is 0.3. So what I need is from 21.8 to K is 0.3. Now, it doesn't actually say, it doesn't say exactly which side of 21.8 it's on, but if we do A correctly, then you find in A that this area right here is 0.925. So that means this area up here is only 0.075, which means there's no way that K can be above 21.8. So that means K has to be down here somewhere. All right, so K is down there. We know that the area in between these two is 0.3. Now from that, we can easily find the probability of getting below the k, right? Because you just take the 0.925, which is all of this, subtract the 0.3, and you end up with this region right here, which is everything below the k. So you should be able to get the 0.625, which is everything that is below the k there. All right. Now with that, you should be able to then go to your calculator and say, well, let's find the value of k by doing the inverse normal of 0.625. You should be able to get that value. You have the mean, you have the standard deviation. That should be all right. So that hopefully is helpful if you had a hard time. Always draw the picture. Pictures will be very, very helpful. Question number 7. I'm not going to go into too much detail, though you do actually have to think about the problem, right? It tells you that f of x equals square root of 6x minus x squared. That means that that's y, right? That's your y value. The x value is just x. In this, it has OP being x. That means this also has to be x. It's a semicircle, right? It tells you that. That means it has to be symmetric on both sides. So therefore, this between P and Q has to be 6 minus 2x. That'll be important. To get the expression for the area, that shouldn't be difficult because it's just the base, which is 6 minus 2x, times the height, and the height is just the y value, and so you just multiply by the square root of 6x minus x squared, and there's your area. Now in part B, you're just finding the rate of change of the area, which means you need to take the derivative. This is a calculator active section. You should just pull out your calculator, you should put that in for A, and then find the derivative at x equals 2. That should be really easy, 1 point, done. Okay, now where most people made their mistake is right here where it says the area is decreasing. Again, I'm going to go back to the area function. I saw people use f of x. I saw people use the 6 minus 2x. I saw people use the derivative of a. This is just the area. So the area is decreasing from a to b. Okay, so the easiest way to do this really is to just graph it. So here's my calculator. I'm just going to put in 6 minus 2x. And then I'm going to multiply that by the square root of 6x minus x squared. And that should allow me to graph it. All right, so there you go. Now, the question is, when is the area decreasing? Well, you can see that very clearly in your graph here, right? You've got your maximum area right there. And then from there to here, it's decreasing. Now what some people did is they went from the maximum here all the way down to there, and that just doesn't work because this right here is an area of 0. When you go down below that, you're going into negatives, but remember you can't have a negative area, so what's actually going to happen is that this is actually going to be positive area now, so it's increasing again. So really what you have to do is you have to have from this point to the 0, and that's when it's decreasing. You'll notice that the 0 is when x equals 3. You can do all this. I'm not going to do all the calculator stuff for you. You can do the second calc and find the maximum and the intersection, all that kind of stuff. But remember the x here is 3. Well, that should make sense because if x is 3, that puts PS in the middle, which means you now have a straight line and the area is 0. As you increase x, it'll move over to this side, which means you're going to end up getting a rectangle again, so the area is going to increase again, right? And so decreasing is from some point along here, and then you keep moving the bars in, increasing x, and as you do that, then it will decrease the area until you get down to an area of 0. Okay, so there is some thinking, some reasoning involved, but really the main thing is you just have to read the instructions. If you read the instructions, then, I mean, you'll save a lot of the points that you guys lost. Points were lost because people were putting in strange things for area when that's all that was needed. Okay, you're welcome to use the derivative here. It is talking about a decreasing area, but you do have to be careful because a negative slope doesn't necessarily mean that the area is decreasing, because once it crosses that axis, I still have a negative slope, but now I've got a positive area. Okay, so keep that in mind. We'll go on to question number 8. Question number 8 was one of the ones that people really had a hard time with. Get comfortable with circles. right? A lot of times the trig questions will have circles involved, whether it be sectors or Ferris wheels or something else, but trig functions are cyclical. They're circles, so they're circular functions, and so that's why it's important that you recognize, be able to put the circles with this. Most people found BAC just fine. Use some type of, most people use sine rule, which is fine. You then have angle A. Then you were able to get AC. Some people used this triangle here, the ABC. You were able to use the cosine rule in most cases. Some people said, well, I've got these two angles, I can subtract from 180, now I've got this angle. And other people just you found one of the sides and use some other combination that way, and that's fine. So you've got that. Now we move on to the length of arc ABC. Now I saw a lot of different ways of doing this. Most people did something where they found AC and then subtracted it from the circumference, which was the whole thing, and that's fine. Conversely, what you can do is you can just find out the whole arc for AB, you can find out the arc for BC and add those together. Now, what a lot of people made a mistake on is that they tried to use the formula, right? You do have a formula, something like this, but the formula that most people used was this one right here. The length, the arc length equals theta r. And so what you did is said L equals theta r, and you said, hey, here's theta, I'm going to put that in for theta, and then I'm just going to multiply by the radius, which was 7, and that should give me the arc length. The problem is this theta has to be a central angle. It has to be at the middle of the circle. And so it has to be, if you're going to do that, then you have to have this angle right here, not that one. Now, some of you may remember from geometry that this angle will be double that one, because this one is inscribed on the circle. Then the one from the center of the circle will actually, if it has the same vertices, the same contacts, points of contact with the circle. So this should just be double that. And you could use that, and that would work okay. What I expect most people will want to do is something where you do this, where you say, okay, well, I can use my cosine rule to find out the length of this side right here. Once I have the length of that side, I can now find the central angle right here, because this is 7 and 7. Those are all radii. So I should be able to use the sides to find this angle. That angle will then allow me to find AC. Once I have AC, I can subtract it from the whole circumference. So there's a number of ways to go about doing this circle question, but most of them include somehow finding one of those central angles, not using these outside angles, which is why so many people lost points there. Okay, so just remember this theta has to be a central angle so that it's directly related to your radius. Okay, question 9. I don't really have a lot to say here other than, for heaven's sakes, draw a picture. I think that some people got confused with this where it said in the line L2. It doesn't say that the point R is the reflection of Q on the line L2. It says in the line. So it's like your reflection in the mirror. The mirror is the reflector, right? So line L2 is the reflector. Earlier in this question you had L1, right? And then you found that L2 was perpendicular, so somewhere here you got L2. And then it says Q is on L1, so there's Q. You had P because P was the intersection. And so knowing P and then saying that Q is reflected in the line L2, L2 is the mirror, so that means that R is just right over here. Because they're perpendicular, R is also on the line L1. And so all you have to do is find out the vector to get from P to Q and use that to get from P to R. Or what you can do is get the vector from Q to P and then add that to P, right? But you do have to be careful that you're paying attention to your directions. If you get this vector, then you're going to have to subtract that from P to get to R. If you use the vector QP, then you should just be able to add that again to P, and that should take you down to R. Okay, so the picture hopefully very helpful there. The last question I thought people did very well on. The biggest issue was people guessing and checking on letter D. Really the best way to do that, if it says that she wants to go to school by bus at least once, then that means that she didn't go 0 times. Okay, so essentially that's what it is. At least once means that it wasn't 0. So if it's a 0.95 probability of going at least once, that means that 0 times needs to be 0.05 or less, right? Because this can be greater than 0.95. And so the easiest way then is to say, okay, what's the probability of her going by school bus, which you use the 0.3 there, right? And then you should be able to figure out, well, knowing that 0.3 is the probability. Sorry, not 0.3. 0.3 was the probability of the bus when it does not rain. So we actually want the answer here. What's the probability that she goes by bus? So you'll use that in conjunction with the number of days. Essentially what you'll have is you'll have 0. I think the answer was 0.66 for letter A, right? Or it was 0.34, and then I'm looking at not getting on the bus. So the probability of not getting on the bus is 0.66. How many times until that is 0.05? And so you should be able to solve this. The easiest way to solve it is just go log 0.66, right? That's an exponential. You get rid of an exponential, I just take the log. So I go log 0.66, and then you should be able to pull up your calculator, and we just go alpha F2, and you've got your log base there. So we go log base of 0.66 of 0.05, and you'll find that we get 7.2. So the 7th one wouldn't be enough, so it has to be the 8th day, so 8 days. All right, so hopefully that's helpful. Obviously, I went through that a little bit quicker because the point of this is not to give you the answers, it's to kind of give you a little bit of an idea of which direction to go in. If you're still struggling after these little hints, you probably need to just come talk to me so I can help you out with it. Okay, so there you go. That was paper 2. Yep, a little bit harder, but there's some good questions there, and definitely prepare you for your IB exam. That's it.